Here we go again, pirates. We've been connecting derivatives and originals and second derivatives. We did it with a formula. We did it with a graph. Guess what we get to do today? Table. These are all the ways that AP is going to expect you to connect these ideas together. So you would be given a table, most likely of the original, the first derivative, and the second derivative. Never fear, it all comes back to the same first step. Make a sign chart. So I want to look at the row for my first derivative. Critical values happen when the derivative is 0, but also when the derivative does not exist. That could be a corner or a cusp, something important. So I make my sign chart of the first derivative. Look, we called it G today. Be careful. This happens at 2 and 5. You might be asking yourself, how do I know if it's positive or negative? Back to second grade we go. 5, is that positive or negative? Positive. So there's our sign chart. In between there, we have something that's negative. And last but not least, 8 is positive. So once you get that sign chart, it starts to feel a lot better and a lot more like what we've been doing with the other two examples. We're going to do the same thing for the second derivative. Critical values happen at a 0 for the second derivative. That's happening in this case at x equals 3. I would encourage you to label your sign chart. That way we know what we're looking at. These are negative numbers, and this is a positive number. After that, everything's the same. If your sign chart is good, all your justifications are going to work right from there. Max-Min's first derivative test uses the first derivative. I look at my first derivative. At 2, I have a positive followed by a negative. I think we're pretty good by now. That would be a maximum. So I have a max at x equals 2. I feel that way. Be careful. I changed the letter again. G prime of 2 was 0. G prime of x was greater than 0 to the left and less than 0 to the right. Keep your seatbelts on. There's a twist ahead. At 5, my first derivative changes from negative to positive. Sounds like I have a minimum. Okay, that seems reasonable. So I have a minimum at x equals 5. But now watch carefully. That wasn't equal to 0 for the first derivative. I feel that way because my first derivative did not exist. That's what made it a critical point for this example, just a little bit different. My intervals look the same. My derivative was less than 0 to the left and greater than 0 to the right. Okay, so we went from 5 to infinity. Next up, second derivative test. Actually, our combo derivative test. Same answers. So we have a max at 2. We have a minimum at 5. This one's a little tricky with the does not exist, but we can still use it. So if I have a maximum, okay, I feel that way because my first derivative was equal to 0. My second derivative, in this case, was negative. Now you're probably guessing that this is a corner or a cusp, so that's going to shake out a little differently, but we can still justify it the same way. So I feel this way because my first derivative did not exist, but my second derivative at 5 was positive. Last but not least, we're going to justify our point of inflection. Points of inflection come from the second derivative, and it changes signs. That happens at 3. So I feel pretty confident that I have a point of inflection at x equals 3. My second derivative was equal to 0. My second derivative in general was less than 0 to the left and greater than 0 to the right. We're not going to graph this function because we don't have quite enough information, but I hope you enjoyed justifying. Good luck, pirates!